Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. In the previous class, we have been discussing about linear momentum. We have discussed the first law of motion of Newton regarding the motion of an object. Today, we will be discussing about the Newton's second law, and the knowledge that we require to understand about the Newton's second law has been already discussed in the previous class. So if anybody hasn't watched the previous video, please do watch the previous video to understand this lecture in a better way. Okay, so with that, let us start our discussion. We have been discussing, today we will be discussing Newton's second law of motion. So write down the heading in your copy, Newton's second law of motion. So what is actually Newton's second law of motion? So it's something regarding force, it's something regarding momentum. Okay, so what is Newton's second law? So let's write down the heading, Newton's second law of motion. So first of all, we are going to discuss what the statement says. There is a statement of the Newton's second law. So what does that statement says? It says that the rate of change of momentum of any body is directly proportional to the force applied. Okay. So once again repeating, the main fact that is about the Newton's second law is that the rate of change of momentum of a body is directly proportional to the force applied. Okay. So just note it down. So Newton's second law states that the rate of change of momentum is directly proportional to the force applied and the change takes place in a direction in which the force has been applied. Okay. So this is the Newton's second law. So it states that the rate of change of momentum is directly proportional to the force applied and the change takes place in a direction in which the force has been applied. So basically we have discussed what is rate of change of momentum, what is momentum, all these things we have discussed in the previous class. So by now, if you have watched the previous video, you must know what is rate of change of momentum. So see, if an object is at rest, it is lying on a table and you push that object or you suddenly apply a force on the object, okay, so it will come into motion, definitely will come into motion if the force is quite large enough. So when the object comes into motion, what happens? There is a change in the momentum because initially the object was rest, and when an object is in rest, its momentum is zero. When it comes into motion, the object starts moving. Now it is having a certain velocity, so mass multiplied by velocity will give the momentum at that instant. So you can easily understand the fact that whenever a force is applied on the object, it is creating a change in momentum. And what happens? This change, the interval, the time in which this change will take place actually depends on the force, the magnitude of force that has been applied. So more the force applied, the more harder you kick a substance. Say when you are kicking a football, the more harder you kick a football, okay, so the change in the momentum will be much more faster in that particular body or in that particular football. Okay, you see, when you kick a football very hard, what happens? You are applying more force, you see the ball just flies off. What does that mean? It acquires quite a large velocity within a very small interval of time. So that is what actually the Newton's second law is trying to say, that the force applied is directly proportional to the rate of change of momentum of that particular body, and definitely the change in momentum will take place in the direction in which the force is applied. So if we apply the force along the say in the eastward direction, definitely the body will move towards the eastward direction. So just let us just understand this fact. So what does the last line say? That the force, the change is in the direction in which the force is applied. What does this statement mean? See, I'll just try to give you an understanding of this sentence through a drawing. Say there is a football, okay, on the ground, and the football is kicked very hard, okay. So the football is kicked very hard. So it's present on a level ground, okay, kicked very hard. Now we are applying the kick in this direction, say, okay. We are applying the kick in this direction. Now what happens? The ball will start moving in this direction definitely, okay. So if I say that the ball is moving in this direction, what happens? The velocity of the ball is in this direction. And as you know, in the previous class we have discussed that momentum is a vector quantity, and the direction of that vector quantity depends on the direction of the force, direction of the velocity. So if the velocity is in this direction, definitely the momentum, direction of momentum will also be along this direction, okay. So the direction of momentum will also be along this direction, isn't it? So this is quite obvious, okay. When you apply the force in the direction, the change in momentum is actually taking place along this direction, okay. So the ball was initially at rest, so initial momentum Pi was 0, final momentum Pi will have some value, and it will be along this direction. Which direction? Along which the force has been applied. So this was what the last part of the law tries to state, or tries to mean, that when you are applying the force in a certain direction, the rate of change of momentum will also be in the direction of the applied force, okay. And more the force applied, you will be able to observe the change in momentum in a much shorter interval of time. So much larger change in momentum in much shorter interval of time indicates that a large force has been applied on the body, okay. Now coming to the mathematical expression. So mathematically we can say that the force applied is actually proportional, and it has been experimentally found out the proportional to be 1. So we can directly write that F is directly proportional, or F is equal to rate of change of momentum. So delta P by delta T. Again, these notations have been explained in the previous class. Please, if you have not watched the previous video, please do watch the previous video to understand this topic. Okay, so F is equals to delta P by delta T. Now you know momentum can be changed by changing the mass of the body as well as the velocity. Why? Because momentum is actually the product of mass and velocity of a body. So when you see you want to change the momentum, either you can change the velocity of the body or you can change the mass of the body. Now, so I can express this as, so if the mass remains constant, change in velocity will create the change in momentum, and if the velocity of the body remains constant, then definitely mass should change. I am saying, not saying that velocity is 0. I am saying that if the velocity remains constant, then the mass must change in order to create a change in momentum. So basically this is the expression for the force. This is the expression for the force. This is the general form of the Newton's second law. But in the major cases, in the maximum cases in the practical life, do you see any change in mass of a body within a short interval of time or in a certain interval of time? It's quite difficult that the mass is changing so fast. So in most of the cases, practical cases, or in our daily lives surrounding us, the various phenomena that are taking place, what happens? This part of the equation, the second part of the equation is basically 0. Why? This part of the equation is basically 0. Why? As because there is no change in mass. Mass is equal to 0. So there is no change in mass. So definitely the second term will be 0. So what does the expression is all about? What does the expression turns out? It turns out to be F equals to m delta V by delta T. Now what is delta V by delta T? This is change in the velocity, or you can say not change in the velocity, rather rate of change of velocity. So what is rate of change of velocity? As we have learned in the previous chapter, that rate of change of velocity is basically acceleration. So this part is nothing but the acceleration of the body. acceleration of the body. So you can say definitely that the expression for force in most of the cases will be mass into acceleration. So you can say that the actual formula for the Newton's second law is this one, okay, and in most of the cases, since the mass change is zero, then we can consider the formula to be force equals to mass into acceleration. Okay, so this is the expression of mass that we use in most of the this is the expression of force that we use in most of the cases. Now, what is the CGS and SI unit of force? You know that CGS unit of force will be force if you are getting the formula force is equals to mass into acceleration, or even if you consider that force is actually the rate of change of momentum. So what is the unit that you are getting? See, the unit that you are getting is, so what is momentum? Momentum is mass into velocity. So what is the unit of mass? Mass has a unit of kg, velocity has a unit of meter per second, okay, and that is by divided by time, so it's second again here. So what does it turns out? It turns out to be kg meter s to the power minus 2. So this is the part of this is the unit of acceleration, and this is the unit of mass. So basically what you get the same unit as the expression F equals to ma. So this is the SI unit, but however we do not use this unit kg meter per second square. Rather, we use the unit Newton in order to give respect to Sir Isaac Newton. We have kept the SI unit of force to Newton. So SI unit of force is Newton. SI unit is Newton. Okay. And what is the CGS unit? The CGS unit is it is dyne. CGS unit is called dyne. Now, what is the relation between Newton and dyne? What is the relation between Newton and dyne? You can definitely have a just brief explanation what is the relation between Newton and dyne. So we know that force is equals to mass into acceleration. So using this form, so 1 Newton is nothing but 1 kg into 1 meter per second square. So 1 kg means 1000 gram, okay, 1000 gram, and 1 meter means 100 centimeter per second square. Multiply these two together, you get 10 to the power 5 gram centimeter s to the power minus 2, and this is nothing but dyne. So this turns out to be 1 Newton is equal to 10 to the power 5 dyne. So this is the relation that you get between dyne and Newton. Okay. So with this, we will be coming to the end of this lecture. In the next class, we will be discussing some of the applications of Newton's second law, and we will be having some detailed discussion on those. Till then, please do study well. If you have any query, mention it in our comment section. We will be happy to solve your problem. Thank you. Goodbye.